Okay, so let's try an example. Let's say we wanted to find the volume bounded by the shape x squared plus 2y squared plus z equals 16. So, hang on, I'm going to say x equals 2 right now. Doesn't that screw with this first thing? Like, what category of object do I mean by x equals 2? Yeah, that's one of the bounds, right? So that's a plane, right? Parallel to the
YZ
plane.
yeah. You guys see that? That's parallel to the YZ plane. So when I say y is 2, that's also a plane parallel to the XZ plane. Okay, and then the coordinate planes, those are the ones x is 0, y is 0, and z is 0. Okay, see that? Those are the xy plane, the xy plane, the yz plane, and the xz plane. Cool? Okay, so I have a bunch of planes and this. What the hell is that thing?
A function.
Or no,
It's a paraboloid. Elliptic paraboloid.
Oh, that's what you meant.
You guys see that? This is an elliptic paraboloid.
Oh, you
It's
just have to
downward
say
facing.
z equal. Okay.
So if we fiddle this around, right, and that's kind of the key here, because I don't know how to integrate volume. You guys see that? Like, we didn't do that yet. So if I don't know how to integrate, I need a function so that I can actually integrate. So I need to solve this thing for one of the variables at least. Right? Like, I would even settle for a function of z and x if that was going to make my life easier, right? You guys all believe that we could do this same theory, chunking up the, instead of chunking up the xy plane, we could chunk up like the yz plane or something?
would you need different bounds if you're chunking it up?
Yeah, we'd need to talk about our bounds, but
And yeah, the other ones would have to.
you guys believe that's possible at least?
Yeah,
Okay.
it just involves square roots quite a bit.
So in this case, right, it's easiest actually to write this as a, what, function of,
Z.
yeah, a function for z, right?
Okay.
So we can rewrite this as z of x and y is 16 minus,
X squared minus 2y squared.
perfect. And now you can see that this is elliptic paraboloid, downward facing, shifted,
Up 16.
up, right? So someplace going on here, there is a downward facing umbrella. I suppose umbrellas usually, you know, sometimes it's windy and then umbrellas don't face down. Okay, so I have something like this, right? I have X, Y, Z umbrella thing. That's good. Okay. Where's my little region I'm supposed to be integrating? Okay, so X is 2 is like 1, 2. Y is 2 is like 1, 2. And then
Everything with negative directions down.
I have kind of this bound, right, and that bound.
First quadrant.
So I'm looking in the first quadrant, right? You guys see that? So I have this as my little rectangle, right? So what's my rectangle? It's R is what by what? 0 to 2 by 0 to 2. You guys all with that?
Yep.
Okay, cool. So how do I set up my integral?
Oh, so
What do you need? You need 3 things, right?
yeah.
We have the bounds.
Okay, so you need,
Yeah, we put that on the integral.
okay, so you want to put down squiggles,
Yeah.
okay? And they're both 0 to 2. Okay, and what are you squiggling?
The z function.
Okay, so you put in your function, and then you need, or dy dx, right? Does it matter?
No.
Probably not. Did I already fix it with the bounds? Nope, right? Because the bounds are the same. You guys see that? So you should make sure, right, that your order of integration matches your bounds. Like that your bounds match your region. But in this case, it's a square, right? So it doesn't matter at all if I do dx dy. Or dy dx, right? Because they're the same. Fubini says they'll be the same. This thing, right, is as continuous could be. So I definitely know that Fubini's applies here. You guys see that? Okay. Can you execute this? Yeah, hopefully. Okay. Let me show you a quick trick, because there are a couple quick tricks that are worth knowing. One of the quick tricks is that you can still split stuff up per usual. Right, so the rules of integrals still apply. So you can rewrite this thing using some integration rules to make your life a little easier. So the first thing you can do is you can say, what the hell? Let me write it up down carefully. So you can do 0 to 2, 0 to 2 of 16 dx dy, right? Minus the integral from 0 to 2, the integral from 0 to 2 of x squared dx dy. Minus the integral from 0 to 2, the integral from 0 to 2 of y squared dx dy. Oh, and there's a 2, sorry. Oh, 2y squared. You guys all remember these rules for integrals? Right, the thing's linear, so you can pull constant. Oh, I can even do one better, right? So I could pull the 16 out of the front of that one. And I could pull the 2 out of this guy, actually. I should have put that out here to make my life a little easier, right? And then, actually, it's worth noting that what do you get if you integrate 1 over a region?
You get the area of that region.
Yeah, you get the area of the thing, right? That's that acre foot thing, right? It's just the volume you get when you put 1 deep. So here, this region is, it's 2 by 2, so it's a total of 4, right? So out of that front thing, you get 64. You guys see that? Okay, and then here, what do you get? You got minus integral from 0 to 2 of x cubed over 3, maybe? Evaluated from 0 to 2, dy. And then here you get a similar thing. Minus 2, the integral from 0 to 2.
Y squared times x.
Good. Y squared times x. Evaluated from 0 to 2. This one is evaluating x's, right? And this one is evaluating, oops,
X's.
also x's. You guys with me? Why do they look so different? You were integrating something squared, right? Why did one end up different than the other one?
Oh,
Yeah, because I was integrating x in both, right? You guys see that? Okay, so I got 64 minus the integral from 0 to 2. What do you get out of that thing? 8/3, right? dy. And then minus, on this guy, you got 2, the integral from 0 to 2 of 2y squared. And then we should be integrating 2y. You guys with me? Okay. Can you cheat that one a little bit?
Yep. Just
It's
multiply
times
by
2,
2.
basically.
Yeah, this is just multiplication by 2, right?
Yep.
You guys see that? So I get 64 minus 16 thirds. Right, because I was integrating, really, you could pull the 8 thirds. And so you got 8 thirds times 1. And then this thing is just how long is that guy? Right, so you're integrating from 0 to 2, so it's 2 long, so you get a multiplication by 2. And then here you got a minus 4. And then what do you get when you integrate y squared?
1.5.
Like cubed over 3. And you need to evaluate from 0 to 2.
Which is another 8/3.
Which is, so I got 64 minus 16 thirds minus
32/3 altogether.
32 thirds. Cool.
And when that actually pulls out, it equals 48.
The whole thing?
The thirds end up, yeah, you end up getting a 16 if you multiply, add the thirds together, so the whole thing ends up equaling
Oh,
48.
yeah. Huh. How about that? That's weird. Right? Because not only did these add together to 48, but also the answer is 48. Dude, numbers are strange. Cool? Questions, deals? What does this number mean?
It's the
The
volume.
volume in that, like, domain.
Yeah, this is the,
Rectangle thing.
right, so you're going to have some funky little piece of umbrella, right? You guys see this thing? Right, that's your cap, right, is this funny little piece of umbrella, and it goes all the way down, right? I don't know what the F I was drawing there. That thing gets bent on the other side. You guys see this? Is that a little weird?
Yes.
Go to Tinkercad and draw this thing. There's a parabola tool. There's a paraboloid tool. So you just drag it and then cut some rectangles off of it, and you'll see that there's a funny little dip on that backside. You guys good with this?
Yeah.
Okay, so what are the units on that?
What was the original units?
There weren't original units.
Units cubed.
Yeah, units cubed, I guess.
So it would be x units times y units times z units, right?
Yep.
You guys see that? So if x units, y units, and z units are all the same, which, you know, frankly, if you're organizing things well, they ought to be, right? Then this would be cubic units of volume, right? Do I know that this is all positive?
0 to 2.
Yes.
I just kind of drew a picture to convince you of that. How do you know
But
that
that
this thing didn't get under the xy plane for part of that thing?
Because the XY plane was one of our bounds.
Yeah, 16 up probably took care of it, right?
Yep.
How can you figure that out? Take the lowest point, right? Where's the lowest point going to be?
0, check that.
So you're like,
You mean one of the
There is your
edges.
highest point. But over your rectangle, right?
Yeah.
2, 2 is going to give you the lowest value. You
Okay.
guys all see that?
Okay.
So you plug 2, 2 in to your original function, which is long gone, and you get,
C, let's see. 16 minus 4 minus 8, which gives you z equals 4.
perfect. So it's positive still, right? So it didn't dip below. So this is actually the total volume under there, not signed volume. You guys need to remember, right, that integrals count signed volume or signed area as opposed to regular area or regular volume. You guys all remember that, right?
So you could get negative. Yeah, okay.
Yeah, so you can certainly get a negative result, right? Which just means there's more area below the xy plane than there is above it.
Yeah, like we
In
could
this
have-
case, it's all above the xy plane. So this is actually just straight up the volume under that surface. You guys good?
Yes.
Okay,
Just
cool.
gotta think of it.
Yeah, just be a little careful, right?
Yep.